to get started, can you introduce us to Strathcona Resources?
Strathcona Resources is a pretty cool place. It's around 180,000 barrels a day, which makes it the fifth largest liquids producer in North America. That's pretty cool size, in my opinion, including operating across all of Alberta, Saskatchewan, and British Columbia, all of Western Canada. So that we're kind of in that middle space of not being really tiny, but not being super huge. And we've also grown relatively quickly. Only in the last 5 years, we've grown from the initial combination of Strathcona into where we are now.
Amazing. And what's the mission and vision at Strathcona Resources?
Especially with respect to the CCS bid, it's kind of twofold. So we're still an oil and gas company. And so we think about a long-term forecast and price of oil. But at the same time, there's a long-term forecast and price for CO2. So our intent is a value focus to deliver low-cost energy while still being on the sustainability side as well. So this kind of works well hand in hand as a long-term sustainable business. And that's like leadership's goal is evident in that with like our CGF deal. We're going to have a product, and we're also going to try what we can to make it a low carbon product.
Amazing. And for those who don't know, CGF is Canada Growth Fund. And if you want to look up more about that deal, you can look it up in the news, Strathcona and Canada Growth Fund. Super exciting update for Strathcona, but also for oil and gas in Alberta, I think. And so then, Megan, could you just tell us a little bit about your role at the company and what you do?
Yeah, as a development engineer, I actually represent a much, much, much larger team. There are a lot of subsurface experts, there are a lot of surface experts, and one of my goals is to support that team in the broader decarbonization strategy for Strathcona. My own background is on the engineering side, so I help in terms of both developing the project, trying to do the economic evaluation, and then getting it executable. And then so specifically as an example for the Alberta carbon capture and storage side, it's coordinating between those surface and subsurface teams, interacting with lovely folks such as yourself at lovely organizations like Emissions Reduction Alberta, and applying for managing other government grants or other government incentives to help the economic justifications for the projects.
Great. Sounds like you're busy. So
most of the time.
Can we maybe take a step back and could you tell us a little bit about what is the current state of decarbonization in the oil and gas industry? And since we're talking about carbon capture and storage, how does that fit into the mix?
Absolutely. I see decarbonization in oil and gas as being a pretty broad portfolio. And they're going to have, like any kind of decarbonization project, will have an impact in terms of the actual emissions changed and likely reduced, as well as cost. So a lot of the drivers behind that are carbon pricing and stricter regulation, especially with respect to methane. Again, I start that off in terms of when I first started with Strathcona, as well as where the regulations have evolved, a lot of the methane reduction opportunities, simple switch outs of pneumatic devices, were low cost and high impact. You want to stop venting methane. So those were tackled first. They were low cost and they actually were a big return, not just in terms of the emission reduction, but not venting methane means that we can sell it instead. Then there's another suite that includes electrification and other just energy efficiency process optimizations. In industry in general, and oil and gas specifically, we're always going to look for ways to reduce energy because it costs us. So things like electrification of drilling operations, process improvements, including applications of SCADA or AI, those kinds of things have actually been ongoing in oil and gas and other industries for decades. So where CCS fits is in that big scale. It actually can accomplish very large emission changes where a lot of, again, the electrification and energy optimization is going to be ongoing, continuous optimization, continuous improvement. And a lot of the early hits for methane reduction have already been taken off the table. They're kind of underway. So we're now left with the really big hits, but that are also relatively expensive to implement.
Great. And we'll be talking more about that, I think, and how you're trying to optimize that here in a few minutes. but maybe one more question around this. So why, in your view, is it so important to decarbonize the oil and gas industry? What's the impact of that?
Stating the obvious, the direct impact is the specific reduction in CO2 emissions. Indirectly, you also benefit from improved air quality, lower emissions like NOx, SOx, particulate matters. They're going to be reduced as like a byproduct. And then specifically for the CCS project that Emission Reduction Alberta is helping fund and where Strathcona is, we have a lucky advantage in our location. So our oil sands facilities where we're going after these projects are directly atop like existing CO2 storage reservoirs. So what that means for the environmental impact and like the how much it's going to cost economic side is the surface facilities that already exist, our oil sands facilities, and then the CCS facilities that we're planning to build are going to look very similar. And in a lot of cases, we're lucky that they're going to be on the existing operation footprint. So we won't even have to like encroach into existing environment to get those done. And we won't have a lot of the burden of long and expensive transportation. It's literally right below us. And then the storage for the CO2 itself will be underground. Thankfully, oil and gas has a lot of experience injecting, producing those fluids. And so we're well suited to also help monitor that. Again, so the environmental impact should be relatively minor. And then we've mentioned it before, well, again, CCS projects are very expensive. And where that money is going to go is a combination of like creating jobs, fabricating, constructing, operating, maintaining. So it's also actually a good potential for an economic injection into the local economy where these projects are taking place. And the nature of how these projects are going to be structured for our internal economics then are then an economic benefit to Strathcona to reduce our carbon tax liabilities. That's like one of the natures of business as well as economic sustainability. But broadly for Alberta and Canada, I'm hoping a very strong potential that it makes our products more industrially competitive because it is a global product. And if we can end up producing one of the lowest carbon products in the world, we're hopeful that makes it more competitive.
Great. Thanks, Megan. Such a great answer. And you touched on so many different things. So we're going to get into talking about the project. So Erie has funded 2 separate projects with Strathcona that are eventually going to merge. And so this is the first in a 2-part podcast series where we'll be exploring both the projects in turn. And this one will be talking about your carbon capture and storage front-end engineering design study. So the engineering work that's going to lead to that big decarbonization project that you were alluding to earlier. So maybe we can start with what is the purpose of doing front-end engineering design or FEED? What does that even mean, and why is it so important for CCS?
Yeah, I really liked actually. I remembered back to when we first applied, and this was kind of titled "The Need for FEED," which was rather clever. So as a just example engineering project, like any industrial engineering project, say it's $100 million. There's rules of thumbs that say the engineering part of it should be around 10%, so around $10 million. And then the front end engineering and design part or FEED should then be 10% of that. And so that's then in the like $1 million range. So why I bring that up in terms of how critical the purpose of doing FEED is and what it means for implementing CCS is one of our assets, Lindbergh, is at around 500,000 tons a year. And if on average we could, and I'm going to make up some numbers so the rounding gets good, let's say we could abate those emissions at around $100 a ton for a 30-year project life, that's $1.5 billion. No one wants to make that decision today, the least of which they're very willing to spend that $1 million up front to help make that decision. And so that's why FEED is absolutely critical. It provides the blueprint and the framework for what actually needs to get done, how much it's going to cost. And so for decision makers, they don't have to leap into a $1 billion decision. And then organizations can prepare from the technical work to the supply chain, sourcing equipment, and even who's actually going to be getting the project done. So also the people management.
Right. Yeah. I think that's a really important point that we're talking about billion-dollar scale projects here. So the feed is going to be on the order of millions of dollars, if not tens of $1,000,000 in some cases. So, all right. So can you tell us about the scope of your feed study at Strathcona and perhaps what's unique about your approach?
Absolutely. The study we broke down into two pieces, one being the upfront high-level feasibility. And that was really to try to guide a funnel kind of approach in the assessment of the technologies. So Lindbergh, where the project is going to be based, is a steam-assisted gravity drainage facility, SAGD. And there were more than 60 technologies that might be applicable for actually reducing or applying CCS there. But they have different qualities, levelized cost, technology, other environmental impacts, like their footprint required or how reliable they'll be. So we deliberately picked the upfront feasibility piece of that first to really try to funnel down which technologies at what level of risk would we be willing to go forward with. And so I'd say that's part of Strathcona's unique approach is there's some technologies, and we can get into some of the details here too, like advanced amines that are ready to go today, but they might not be the best cost. And since our approach is that value-driven long-term strategy, we're also going to strongly consider the lowest cost. It happens in this case that the lowest cost one might not then be the most technologically advanced or ready. And so we've decided to approach the feed side of this study with both. We want the opportunity to look at the lower cost technology as it's being developed for that long-term view, while also understanding that what's currently available is a reasonable technology approach, and we want to understand the cost of that better. So ultimately, we're going to drive towards a plus or minus 20%, plus or minus 20% cost estimate in order to make those final investment decisions.
Right. Yeah, I think it's really strategic that you guys are looking at those trade-offs between cost and readiness. And also, I'll just say, I think relatively unique to cast the net and to look at all these different technologies and be willing to consider innovation for CCS. And I think that's just really important to the overall commercialization of CCS. So, all right. So we're about 2 years into the feed study now, or into the project with ERA. So I was wondering if you could tell us what is the current state of the project, and are you seeing any interesting results so far?
Absolutely. It's the current state is we've finished the feasibility and we've kicked off the feeds, the more detailed look at two technologies. What's been surprising is something that we've stated earlier is the most technologically available and ready approach is not necessarily the lowest cost, and vice versa. So not only are we putting our eggs in a couple baskets in terms of technology, but we're also still looking at a staged approach, both in terms of the equipment that we're planning to abate and the relative scale, so that this is a longer term view. We're going to take this multi-year technology review and really select down specific vendors, specific technologies, and kick those off. It's pretty exciting.
Yeah, it's super exciting. Great. And maybe you could tell us how has ERA funding been used for the project? What was the impact of that funding?
I was actually thinking back to the initial application and when we first met with yourselves and got more involved with Emission Reduction Alberta. In early 2022, when we did this application, we were staring down a 2030 $170 a ton carbon price. And so where ERA's funding and this project comes in is a huge enabler, an absolutely critical enabler for getting this project off the ground. So as I mentioned earlier, one of the desired outcomes is that it's a key ingredient towards that financial investment decision, the FID. But the feed studies themselves are costly and can sometimes represent a barrier if, for example, during the timing of when you're wanting to kick those off is at the tail end of a pandemic where we suffered negative oil prices, and we're talking about risk dollars. So by covering 50% of that pre-construction design and engineering, ERA's contribution has helped mitigate that upfront financial risk and actually help enable this getting off the ground sooner than what it may have otherwise. Without ERA support, the timeline that would likely have been delayed and may have even impacted the project's opportunity cost, like the ability for the project to understand that there are potentially technology innovation benefits. And then, as you're aware, there are other financial incentives like the investment tax credit. And so we might not have then had a project ready to actually use those incentives towards these emission reduction goals.
Yeah, that's really great to hear, because I think the International CCS Knowledge Center had put out that need for feed report, I guess, sometime around then, and then we launched the Carbon Capture Kickstart Call, it was called. So it sounds like it did kickstart the project, and then, as you say, it kind of helps unlock those larger federal incentives that have come into play later. So it's kind of amazing to look back, actually, everything that's happened in this space in just the past 2 years. All right. And then, okay, so then I think you alluded to this earlier, but could you give us a sense of the scale of emissions reduction that your project will ultimately achieve? Let's say, FEED is successful and you go forward. What does that look like?
Absolutely. So Strathcona as an entity, more than 80% of its direct emissions, so not including electricity, just direct emissions, are from our thermal SAGD operations. And that's in large part due to the combustion of natural gas. So again, I've tried to round numbers to kind of keep it simple. If Strathcona's direct emissions are 3.4 million tons per year, and 100,000 of those are from methane that, again, are more likely to be easily abated by stopping venting, that kind of thing. On our Saskatchewan thermal side, they're around 1 million a year. And then on the Alberta side, Tucker is around 1 million a year. And then Lindbergh and Orion are each 500,000. Such that all of our direct emissions from the combustion of natural gas are close to that 3 million tons per year of the total 3.4. And so for the relative scale of what we're targeting for CCS, for CO2 capture on a technical basis at 90% or better capture rates, if you applied the 90% against the 80% of emissions, we could actually, as an entity, as all Strathcona, achieve an overall reduction of up to 80% of our emissions. So that, like, going back to where CCS fits in the decarbonization chain, it's the game changer. It's like the biggest chunk of emissions you can actually achieve in terms of what that reduction looks like.
Great. Yeah, that's super exciting, and just going to make such a big impact if and when it goes forward. So now we're going to switch to talking about the challenges with the project. But before we talk about the project, can you tell us what are some of the biggest challenges that you've faced in your role?
Technical complexity. I am an engineer by trade. I like to think that I'm relatively smart, but these are not simple projects that we've executed 100 times. They're technically complex and expensive enough that a mistake will cost a lot. On top of which, they're most often on brownfield operations. So you don't get to build it from scratch. You're trying to bolt on or integrate into existing systems. So the technical challenges with those are, they're also organizational, but they're not, they can't be understated. That makes also one of the challenges just staying up to speed on what the new technologies are and what those hurdles actually include. At the same time, there's also the evolving regulatory and policy landscape. So we're trying to navigate the regulations and policy at the same time that in some ways that they're being evolved. So it's a lot of perseverance, agility, and patience, because it's a double-edged sword. Sometimes, like, the uncertainty makes it tough to know which way to go, but also gives industry that opportunity to collaborate on the creation of some of the regulation. So it's challenging, but good.
Everybody's kind of in it together right now, sounds like.
Exactly.
Maybe could you tell us what are the top most interesting things that you've learned in the course of doing feed so far?
Yeah. The need for that balance between the technology risk and cost. So really the transition I see between a pilot project and commercial scale would be something that I've learned tremendously is you're still wanting to take that staged approach with pilot or demonstration projects, but test the waters too with a few commercial implementations. So trying to balance that technology readiness and risk. As I mentioned earlier, the patience and perseverance, just have a lot of faith in that long term view, and that although regulations and policies may change, and it's important to stay like on top of them, it's also important to be patient with it and accept that it's going to change and that you can adapt to that. And another key learning would be early collaboration. These challenges are multifaceted. Again, I described that I really only represent a much broader team. There's subsurface experts, there's surface experts, there's organizational experts, and trying to understand those along the way is incredible. And I would argue that ERA is one of those examples. We really have felt more like partners with Emission Reduction Alberta so that we can learn together, and those knowledge sharing sessions are a huge part of the top three things that I've learned.
That's really great to hear. Any other challenges you want to mention? You think you've given us a good sense of the complexity of this and just how many people and also just types of expertise it takes to do the feed.
There's also going to be some challenges for our industry, in part given some of the incentives that have been created. So, as I mentioned, we have a long-term belief in both a price of oil and a price of carbon, but they can sometimes for the system be challenged against one another. So that's sometimes when you look at the system in place for Canada as compared to the United States and those balancing incentives and carrot stick regulation pieces. So there's the natural technology and investment driver that happens, and that becomes a challenge. But it also can sometimes affect the people, the time and resources involved. If the investment goes in one direction, the people often go in that direction too. So it'd be, be something we still have to navigate in the future.
So speaking of the future, I wanted to shift to kind of a forward look for the project. So what's next for the feed study project? What are you hoping to accomplish over the next year?
The next objectives are with the more detailed engineering work that includes some site-specific application. So some of that site-specific stuff is literally how much space is on the lease. Where is it going to be? How are you going to ship to that specific site? It turns out they don't all have post office boxes. So you have to include then supply chain, how you're going to get there. One of the key driving outcomes is still that plus or minus 20% cost estimate to make the final decision, and then get over any kind of major hurdle for funding that project.
And can you tell us a little bit about the Canada Growth Fund announcement? We talked about that very briefly at the beginning, and that's another kind of example of one of those federal incentives that have come into play in the past, more recently. But I would love if you could tell us a little bit more about that and how that impacts the CCS project.
Absolutely. The funding is one of the major hurdles for most CCS projects since they're so capitally intensive. So with the Canada Growth Fund, we're kind of balancing the risk with the Canada Growth Fund, the technology risk, the price of carbon risk. That is to say, our phased approach. So it does balance other Strathcona assets in Saskatchewan as well. But we're taking that phased approach of the size of the CCS project, the equipment that it's going on. We're doing that hand in hand with the Canada Growth Fund. So every final investment decision or FID goes project by project. And so it's a really unique approach, and it impacts our project in general of crossing over that financial hurdle. What's going to be the backing for this and what's going to be the price on carbon? Let's decide that together as we learn more.
And ultimately, it gives you more certainty around what your cost looks like because you have a kind of a backstop around the price of carbon, and that's so important in this space. So given all the work you guys have done over the past couple of years, all the big stuff coming up this year, what does the path to final investment decision look like for CCS at Strathcona's facilities?
Absolutely. The path to FID looks long and phased, but as a balance for that risk and opportunity. We will hopefully also learn as we go with each of these projects. Again, whether it's the specific project that Emission Reduction Alberta is helping to support in Alberta, or some of Strathcona's broader projects in Saskatchewan, we're hoping to learn along the way for each of those FIDs. And so the path looks phased, but deliberate. And it, like I said, balances the risk with the kind of opportunities.
Yeah, so maybe I'll just clarify. I think the project that ERA is supporting is looking at a specific CCS on specifically the Lindbergh asset, but you guys have multiple assets across both Saskatchewan and Alberta, and there's ample opportunity, I imagine, to kind of crosstalk between the different feed studies that are happening in parallel.
Learn from each other.
Speaking of that, let's talk a little bit about knowledge sharing. So you mentioned this earlier about knowledge sharing. So what is the biggest benefit your project will provide to overcome some of the broader systematic challenges that you've talked about? And specifically, how might your project actually help others who might be looking to implement CCS?
So what we feel we can learn, not necessarily about the specific technology selected, but rather about the technology selection process, is something I think will be applicable then not just to Strathcona, but to other participants in our industry and others. So within the CCK challenge, we've interacted with other oil and gas companies, but also cement manufacturer, also a power producer. And so it might not be that the technology we've selected itself is helpful for them, but the process that we took to select that technology is helpful.
Yeah, I think that's really important just because the oil and gas industry probably tends to have more experience aligned with CCS than some of these other sectors that are looking at CCS. So knowledge transfer from the oil and gas industry, I think, is actually critical to helping CCS overall in some of these other industries.
Yeah, we were both at the GHTT 17 last week, and one of the big eye-openers I had was that every broad industry attempting CCS actually has a similar issue. Like, they were not designed to approach CCS. They were designed to produce electricity, produce cement, produce oil and gas. And so having the crossover of other folks trying to implement CCS in other industries that were not designed for it has been the biggest, both like learning for myself, but also that we can offer for others. We might have a slightly more subsurface background than a cement producer. But the electricity or fertilizer production folks might have a better sense of industrial processes and brownfield application. So it's come both ways.
Cool. Okay, I have one more question for you, and this is kind of a big question, but I'm interested in your view. How do you see the oil and gas industry, so your industry, evolving in the next 5, 10, 25 years?
My perspective on this has come a lot from talking with young folks and trying to recruit them into industry. So I'll also start with a bit more of my background. I'm a mechanical engineer who specialized in reservoir engineering for 10 years before getting my master's in renewable energy and engineering management, and then coming back to oil and gas with that CCS focus and decarbonization focus in mind, because I didn't see the oil and gas industry going away. So a lot of the perspective I hear is it's a sunset industry, there's other opportunities. And so where I see the oil and gas industry evolving is in that human capital side. It's in how are we going to attract folks, and this is arguably one of the coolest ways to do that. It's with a really technically challenging project that hits multiple dimensions and is part of what keeps the industry applicable, going, and still allowing folks to use oil and gas products in what continues to be a huge demand for that space. We all enjoy a lot of technology advantages. I like traveling, and I often think planes are a bit of a mess these days sometimes. But I also always think it used to take 3 months to get us there if we were to cross the ocean, and half of us might not make the journey. So I think we've all agreed we like living in this industrial technical space, and we'll need oil and gas products to do that. So where I see it evolving, the industry is towards those lower carbon products, and then offering the opportunities for people, especially our young people, to come along with us in that.
What a great note to end on. Thank you so much, Megan.